Okay, peak index in a mountain array. Let's call an array A mountain if the following properties hold. If the length of the array equal or larger to 3. This is always the case. So since the input will always start from 3 or bigger to 10,000. And the second case, there is existing sum. So from index bigger than 0 to the length -1, there is no equals. There is this case applies such that at some positions, let's call it AFI, everything on the left side is less than it, and everything in the right side is bigger from it. So they will you just need to return that index. So I think if you want to go and find that in for loops, you can, but this could be really expensive in terms of complexity. So the idea is just to find the biggest number that the values next on the right is bigger than it, and the values on the left is less than. So for example, in this case, the index is 1. In this case, the index also is 1. So it's 2. This is the peak. So I think a good approach is to use the same logic behind the binary search. So to divide the array into multiple sets, starting from a middle for each sub-array. And for something we need to keep in mind. So let's say this represents our array. This is the peak. For example, if the first time we took an array and divide by the middle and check the middle value. So we need to find 2 points each time. The midpoint and midpoint plus 1. So for example, if our midpoint was here and the one next to it is less than the middle point, we should check for a peak in the left side of the array because we need to go up. And if that's not the case, we need to go to the right. I'm not sure if the mountain image helps, but this is one of the things that have been discussed in this lecture, the peak finding lecture. I will put a link in the description. But yeah, I think I will just show you the code. Maybe that will make more sense. But that's it. So first thing we need to check. Or no, I will create a separate function for it. So I'll call function binary search 2. It will accept an array left, right. So in binary search, the array should be sorted, but I'm not using the exact way in binary search. I'm just using the logic, the divide and conquer logic. So when we reach a single array, when we reach an array with single element, which means the left index will be equal to the right index, which means we found a left. And second thing, based on our criteria, there is always a peak. If you think about it, that might be a little bit hard to understand, but there is always a peak since the number after the 0 and below the last element is always applied in this based on this criteria and this criteria as well, if you think about it. So we don't need to find a case that we don't have a peak. It's like not a mountain. So that's why when we reach this case, we found a peak. Return left or right doesn't matter because they are equal. Other than that, we need to find 2 points. So mid one will be math.floor left plus right over 2. I won't solve this in C++ because you can easily convert it. In C++, the only thing will change. You add types and you won't floor it because they are integers. So yeah, I'll just do it in JavaScript. And the second thing, this is mid one is the normal thing we do in binary search, but here I will compare it with the element next to it on the right. So mid 1 plus 1. This is the indices. So I will check. So if array of if the element in index mid 1 is bigger than the element of mid 2, I'll just return binary search 2. I will pass the array, pass the left. So I need to go to the right side of the array. So I will start from left. So first time the left will be 0. From the second iteration, sorry. After this, we apply all these calculations. So lift from 0 to the mid. Sorry, to mid 1. And if that's not the case, I will need to go to the right side of the array. So now I went to the left side of the array, left to mid. Now I need to go from mid to right. So return binary hash to the array from mid to right, and that should solve it. But we need to call it, of course. I hope I explained it correctly. Maybe if you take a couple of examples and run through this code on a piece of paper, like try to debug it manually, you will find, or a debugger. Same, everything works. So pass the array 0. I will start from 0 and to a dot length -1, and that should be it. Oh, of course. I need to return something. Okay, submit. Okay, it's really fast and does not use that a lot of memory. So, okay, thank you.